So, Vanakkam. So, we will continue our engineering seismology lectures. So, we have been talking about the Indian code. Okay. So, we told that the prime importance of any seismic zonation is to provide design parameters for the normal buildings in the country. So, that is how the Indian code also is being developed. So, I am not very sure we have discussed in our class what was the first recorded earthquake or instrumented earthquake in India. So, I think we have discussed about the Shillong earthquake and then the Oldham studies and followed by the first seismic instrument deployed in India. So, if you see the first seismic instrument installed in India and the code released, you can see almost there is a huge gap since historic times, but there is no codal provision was developed until or after independence only we had a first code provision. So, that means before that whatever the construction happened in the country, these are all happened based on the experience gained by the people. Okay, whatever buildings which was constructed long back, okay, so such as our heritage temples and then old buildings, these are all based on the experience gained by the people, not the engineered structures, okay, which claimed to be a civil engineers today, and where there is a lot of calculation and mathematics they talk and all those things. But in fact, many of the historic structures are intact and not failed due to the natural hazard. You can see that there are temples, okay, which are 1000 years old, several thousand years old, dams 1000 years old, like there was a dam, okay, Kallanai, okay, so where it is like almost like more than 2000 3000 years old, nothing was happened to any of the natural hazard. Okay. So, the practice was based on the experience gained by the people, which was very intact. So, but still the new, okay, the new way of civil engineering, which was the modern concrete and then the reinforcement, all those things which was developed elsewhere and also adopted in India. So, those kind of technology design needs a seismic code to be considered, because our traditional practice, if you adopt a traditional practice and design a building or construct a building, you will sure that your building may not get affected by the earthquake, whatever traditional practice. But you should adopt that was practiced about maybe 200 300 years old technology you should adopt, not the modern technology. So, the modern technology is basically RCC framed structure, concrete structures, all those things like cement, so many things. So, where this needs some kind of systematic engineering, calculation and adaptation for the sustainability. Okay. So, that is the basis for the creating a seismic code to recommend a seismic zonation map and also give the input for the design of building. As we have seen that the first code work was started in 1935 by Geological Survey of India. Okay, so then it was basically prepared a zonation map of the country by considering the 7 zone. Okay, the 7 zone starts from 0 to 6. The 6 is actually as a intensity reported or expected as a 11. Okay. So, where the 0 is actually 5. But after that preparation of release of that zonation map in 1965, there was a earthquake in Koina. It was 1967. Okay. That Koina earthquake happened in the zone 0. Okay, seismic zone 0, that earthquake was happened. So, that created a puzzle. People found that the seismic zonation what we are adapted based on whatever way, okay, the old seismic zone map how it was prepared, there was not clear details are available. It is only written that it is based on the intensity value reported in the different part of India. So, that means whatever we had a limited knowledge about the earthquake in the last 50 years or 100 years has been taken as a input to prepare a base seismic zone map, which was released as a codal provision of IS 1893 zonation map of 1 during the 19 62 and 65. That is the period, the first zonation. So then they felt that there is a need to revise a code. Okay, so what they did basically, the Koina they pushed into the zone 4. Okay, so they removed zone 0. Okay, so what they did, they tried to also include a geology and geophysical data which was done at a selected location in Bangalore. So removal of 0 zone scientifically reason with no seismicity cannot exist. There is no seismic zone 0 in the country. Okay, that was a zonation map update has been done. The another addition was that merging up zone 5 and 6 as a one category. So now the seismic zonation version 3 which was published in 1970, okay, is as a 5 zone starting from zone 1 to zone 5, where the 1 indicates that there is a some kind of seismic activity. Okay. So then the each zone was assigned probable intensity respective scale. So the 5 close to the intensity 9 and the zone 1 close to the intensity 5. So the upgraded map placed Koina around zone 4. Okay. So that is what update has been done. So this is basically your the table indicating the your seismic zone respective maximum probable intensity. You can see that until 1970 also we have been talking with intensity as a basis for the your code. So but in 1935 45 itself the seismic moment concept has been developed universally. People started using the magnitude as a scale. So in 1984 the zonation map was modified again. Okay. So where the regions different seismogenic potential were identified on basis of the past earthquake and regional tectonic features. So the regional tectonic feature has been incorporated in the code in 1984. However, the map does not show the seismic hazard at different location and failed to assess return period required design seismic coefficient for the source zone. So we didn't estimate systematically the hazard values and we didn't assess the return period, which was one of the mandatory requirement for enemy seismic zonation map. Okay. So we until 1984 zone map also. Okay. So during that period people are even talk about the increasing the doing the probabilistic seismic hazard analysis. Okay. That is what they are start talking in the world. So this was done. The occurrence of 1984, after the 84 codal revision, there was a earthquake. Okay. So of magnitude 1993 there was a earthquake of magnitude 6.3, which was MB, which is occurred at Latur. Okay. So the Latur there was a earthquake where the intensity 9 MSK scale has been reported in the region where the intensity 5 was basically expected. So this was Latur was in zone 1 as per 17 revision. Okay. So but the earthquake occurred was 6.3 and caused intensity of 9. So this put a question mark on reliability of the seismic zonation map in 1984 version. So then followed by there was another earthquake in 1997 in Jabalpur, there was a magnitude of 6. Then 2001 the Bhuj earthquake. Okay, all this put the pressure and then the country tried to revise their seismic zonation map. Okay, so which was the 4th revision of the seismic zonation map which is done on 2002. Okay. So this map basically has been modified as from the 1984 map where they removed basically the zone 1 completely. Okay. So the seismic zonation map 84 has been updated in 2002. So where the zone 1 and 2 were combined together, peninsular India was modified too. So now you can see the difference. So this is the older seismic zone of the peninsular India. This is the newer seismic zone. You can see the pattern of distribution of the zone itself. Okay, the new zone placed the 1993 Lartur earthquake into zone 3. Okay, earlier it was zone 1. Zone 5 has been the most vulnerable of the region, which is generally north, okay, so northeastern part and then the Bhuj region, and some of the country most devastating earthquake occurred in zone 5 are Andaman Nicobar Islands. These are all the regions. Okay, then the entire northeastern part, this one, so the part of India, northwestern Bihar, okay, so the Kangra Valley and Himachal Pradesh, eastern part of Uttarakhand, so all these places. The Kutch region and Kutch, Jammu and Kashmir, which we have already so has been classified as a zone 5. Okay, so this was released on 2002. Two major metropolitan cities, high population density like Delhi, zone 4, and Kolkata, boundary of zone 3, 4 in the zonation map. 4 seismic zones of India were assigned a peak ground acceleration of so much. So you can see that the from intensity we upgraded to the PGA by conversion or by linking. If you recall your global seismic hazard map what we discussed, which was developed in 1992 by the Bhatia et al. So where you can see this discussion was matching with that. So where that PGA was gone as a reference, the zone wise PGA has been given. You see zone 2.1, zone 3.2, zone 4.25, zone 5.4. Okay. Besides the ground motion expected minimum intensity of shaking in each zone also estimated, and this is the value. You can see that zone 1 6 and below, zone 2 and zone 3 is a 7, zone 4 is 8, zone 5 is actually 9 and above. So this is the expected intensity one can expect from the each seismic zone. So this intensity value is only converted as a PGA and used here. So this map further updated in 2016 as a seismic zonation map of the country. So in this actually there is no update of map, honestly speaking, it is only changing of color, okay, and then some informations are added. There is no map has been updated. You can see the both the map actually has a similar pattern. You can see the this one color pattern only basically changed. You can see the color pattern are changed. So here also the same 4 zone concept has been extended. Okay. So here the modification what they have done was the previous version of the code, the design spectrum given up to 4 seconds. The highest value of the 4 second. Here they made it to 6 second. So that was the one of the modification. So then the previous version actually doesn't include necessity of temporary structure to design for seismic provisions. For temporary structures means like this some kind of Kumbh Mela or some kind of meeting or any temporary structures during the construction stage. All those things are temporary structures. That is earlier no need to design for the seismic provision, but now they made that as a mandatory for the all temporary structures should also follow a seismic design requirement. Okay. So that is what, that is also one of the revision it is taken place. The provision to introduce ensure that all the buildings are designed at least minimum lateral force which is given in the code. Okay. So that was the ensure. Simplified method is introduced for the liquefaction. You can see that the first time the liquefaction term has been introduced in the code only on 2016 version. So where 2016 is the era, throughout the world liquefaction attained a stage where there is no more further development needed in the estimation of liquefaction potential, where we started introducing the liquefaction potential. So this is the typical design spectrum given in the code. So this design spectrum identical in the older version, there is not much change. Here we can also see that okay, they give SA by G. So SA by G and natural period. There are 3 classification. Okay, this is a soil, rock and soil. Okay, medium soil, soft soil and rock. Okay, so this is the rock or hard soil. Okay, this is the medium soil, this is the hard. So here you can also observe that there are two type of pattern. For one is that for the equivalent static method analysis, they given horizontal force up to this period will be equal. When the soil comes, you should increase only this period. Okay. So when you want to talk about the design acceleration coefficient based design or response spectrum. So you can see that this is the acceleration zone, velocity zone, this one, then the displacement zone. Okay. So 3 zone was given, but still the values are capped to 2.5. Most of the modern countries they use different value for the different soil based on the analysis and recorded data estimated. Okay. So this as such the spectrum given in the code. So we had a chance to review this spectrum. This was actually developed way back during 1930-40s based on the some earthquake data from western countries. That shape has been adopted in the older version, that has been retained even today. Okay. So that means there is no systematic design spectrum developed for India considering the Indian data. So there is one more thing also, you can see that entire 4 zone, even though we classified the seismic zones in India as a 4 major category, the entire 4 zone the same spectral shape has been used. There is no change. For example, the peninsular India and active region North India may have different spectral shape because of the change in the source, path and site, which is not explicitly represented or reflected in the design spectrum given in the code. You can see that. Okay. So those information, if you want to study more about that, recently we have done the extensive work on this and try to develop how the design spectrum of North India and South India, like active region and intraplate region varies by carrying out a systematic regional input based analysis and publish a design spectrum. Those who are interested, you can basically verify those publication and check. So as and now, this is the design spectrum given in the code, which is classifies soil as a 3 major category, where all the PGA was capped to 2.5. So that is the reason when they talk about the seismic code, they said that when you design as per the seismic code, it does not ensure that no damage will occur. It is ensure that there may be a damage, but only there is no collapse. Okay, that is what discussed in the seismic code. Okay. So there may be earthquake damage can occur if you design as per IS code, but it will not prevent a complete damage. But even though IS code categorically specified that for any important structures, which has a tall structures, many people living like apartments, dams, bridges and then the nuclear power plant, there should be size specific study has to be taken up. But as per my knowledge, none of the apartments, people who are 5,000, 4,000 people are living, nobody does any site specific studies. They construct as per IS code, even though it is very categorically mentioned. So how reliable whatever you do. So now you can think of your Delhi earthquake. As I told you that if there is a earthquake in Delhi, if somebody designed their code, building as per the code, somebody designed their building as per code, you can expect that no collapse scenario happens. If in case if they don't design, then there may be issue. Now you can also see that the liquefaction concept has been introduced in the code only on 2016. That means before that whatever building designed, the liquefaction is happening since historic times. Nobody can prevent that. If the soil is liquefiable, if earthquake comes, liquefaction will happen. There is no way one can prevent. But the design consideration is not given in the code olden days. So how that is taken care, nobody knows. It has only people who are constructed, people who are living has to take care. So in US based system what they do, that is why they categorically revise the code every 4 years once. In India you can see that the first version of the code come into picture. 1962, 1970, 1984, 2002 and 2016. So all this revision happened after major earthquake, not the periodical, because if you see this is the 8 years, 14 years, so this will be again 6 plus 10 plus 6, so the 18 years, correct na? So 18 years, so this will be again 14 years. So this is our code of revision. So in US based system, what they do, soon after they release a new code, now 1 hour gap they start working on the new code for the next year, next revision. So they incorporate each and every component which is responsible and causing a damage at any dwellings in the urban area. Okay, but in India the liquefaction is introduced only on this one, and the soil classification, you can see the classification, 3 major category of soil, which is nowhere represent a amplification happens actually. So this shape has to be arrived based on the regional data, like you should have the recorded earthquake data from each region and try to extract the data for different site condition, or you can create synthetically data at a bedrock condition and study response at a different soil and try to generate a spectrum that will be more representative than this spectrum. So presently some of my research group team, we are working on basically developing a design spectrum for North and South India separately. So maybe we will come up soon with the spectrum which may be recommended for the codal provisions also. So when I talk about the liquefaction, again there was a set of well established criteria for the liquefaction assessment of the site. Okay, so there are so many factors which affects a liquefaction, but as on now estimating that factors itself a question in India. Okay, so for example, for the liquefaction analysis one has to calculate a corrected SPT n value, because there was a liquefaction resistant cyclic resistance of soil. Okay, that is the cyclic resistance of soil which is based on the SPT n value, which is basically n measured per the n 60% energy, because these correlations are applied for the 60% energy. In India nobody measures hammer energy as on recently. Okay, up to 2019 nobody measure SPT energy during the SPT test. So first time we have developed a SPT hammer energy measuring apparatus and measured hammer energy, which was yesterday one of my student actually defended his MTech research. We noticed that the energy varies from 20% to 65% based on the equipment manpower. So this place value in N60, which is again responsible for the cyclic resistance ratio and liquefaction. So this is what is. So this liquefaction criteria, even though mentioned in the code, which is not explicitly discusses what is the state of art knowledge has to be considered for the liquefaction assessment. Okay, that was the one of the major drawback. And the second, the landslide and the tsunami is silent in the code. There is no provision for accounting the landslide and the tsunami. So as such the code given, okay, so if you observe very closely the code development, actually you can see that our code being developed soon after the major earthquake, except 2016 version which was developed after gap of 14 years. But most of the other previous version was developed after earthquake. So India, like peninsular India, considered as a stable and low seismic region once, okay, because there is no earthquake. But after 1960 there was a Latur earthquake, Jabalpur earthquake, Koina earthquake, these Bhuj earthquake. These earthquake damages are much more than the any earthquake in the last 50-60 years in India. That means the damage caused by this earthquake, okay, or the damage experienced by the South India is much larger than the North India in the last 60 years of earthquake history. So that means if you use this data to predict earthquake risk and fatality model, basically you end up in the less earthquake damage for North India, more earthquake damage in the South India, because the history data we have. We don't have the complete history. There was some major earthquake which is reported in olden days, but that damage histories and isoseismal maps are limited. Okay, particularly damage data are limited because the 2002 one earthquake and then the Jabalpur Koina earthquakes are the well known and well studied earthquake where many scientists are add a knowledge to do research on that and then also study the this kind of. So that means the whatever model, okay, so which we consider based on the past, one has to be very cautious. So using this kind of South Indian based data, if you predict a model, okay, so in the North India you will end up in the this one. And you can also see that even today our seismic zonation map not prepared for the future seismicity. That means you can estimate hazard assessment systematic procedure, like I have shown a seismic hazard map, deterministic and probabilistic map of Bangalore. Similar way there is no estimated hazard for the zonation. Zonation map was based on the past seismicity and the intensity reported values, not based on the estimated values. Okay, that is the one thing. Second, the most of the modern code, okay, in the world, they given the seismic zonation map for the based on the probabilistic seismic hazard analysis. They say that like 10% probability in the 50 years, okay, which is roughly return period of 475 years. This we will discuss later class what it mean really. Then 2% probability in 50 years. So they say that the recurrence model has to be represented. So you can take, like I want to take 98% non-occurring, okay, so the 90% non-occurring, 50% non-occurring, like that you can define different probability of occurrence of particular G value which you want to design. But that kind of provisions are not made in Indian code as on now. Even though there was some studies by the NDMA basically did a systematic hazard analysis of the entire India by carrying out a seismic hazard analysis and developing a new GMP. But unfortunately, all the GMP developed by NDMA is only considered a synthetic ground motion data, which is not considered the recorded data. Only for the validation purpose they consider. Because of that, the validity of that NDMA map itself a question, which is not directly incorporatable in the IS code. There was a objections, like people like me, I have been told that the GMPs what you consider is not, may not be appropriate. Okay. So that is the reason the NDMA 2010, even though they published probabilistic seismic hazard map of India, which is not explicitly considered for the Indian zone map represented, but North and Timbajam work somehow represented the entire India in a larger scale and used state of art the GMP model and data and produced a zonation map. So now you can compare a current seismic zone map and then the North and the Timbajam map. You can see there is a similarities and dissimilarities between these two maps. Okay. So the one was basically predicted systematic hazard analysis. The another was based on the past seismicity. So here I can also say that the prediction of seismic hazard as on today, whatever world follows, basically considers more weightage to the places where already earthquakes are occurred. Okay. So there was a earthquake in the before 100 years or 50 years at particular location, it gives more weightage. But I believe that giving more weightage to the recent earthquake location may not be appropriate when you want to consider your future earthquake design. For example, I am sitting in the Bangalore. Bangalore has an average return period of magnitude 6 and above, more than 300 years. Okay. So there was a earthquake before 50 years next to somewhere. Okay, so near to some region. So if I consider that and estimate a hazard, I will get more hazard. But since it was happened before 50 years, next 50 years I am giving this map, or next 5 years basically. That is what we should do, not 50 years, 5 years. In that case, the structural life may be the 50 years. The 5 years people who have designed, they consider the life of building as a 50 years. So this map what we give for next 5 years at least should consider the 50 years return period of those earthquake. So the earthquake already occurred. Next 50 years may not occur because it has a return period of 300 years. So considering same location, more weightage may not be appropriate. That is what I believe. So that concept we actually need to be incorporated in the hazard analysis, but the conventional hazard analysis, that kind of concept has not been included. Okay. So they take probabilistic by variation of the different source and the distance, which is somehow indirectly taken care of this, but still you can do explicitly analysis, particularly DSHA, which is not explicitly included. You can come up with the new method of hazard analysis, which we call it as a rupture based seismic hazard analysis. So right now we discussed about the Indian code. Okay. So the next few classes we are going to talk about the seismicity of India. Okay, seismotectonic of India. Okay, the seismic models, okay, developed in India are applicable to India, and then followed by the seismic hazard analysis, deterministic and probabilistic procedure. So that we are going to discuss in the next couple of classes, which are very important. So the doing seismic hazard analysis of any regions by different way of approach itself you can publish as a journal paper. So most of the discussion what I make in the classes, which has been taken directly from the different publications and updated research, you may not find any textbooks directly, but my PPTs are will give the details. If you prepare that for the exam point of view, these data are more sufficient to fulfill your requirement for the exam. So as we have seen that the Indian code, okay, the first Indian code was released on 1962. So 1962. So then followed by it has updated in the 70 and 84 and 2002 and 2016. So all this version, the design spectrum remains same. Okay, this is the design spectrum. Most of the version it has been used. There is no change. Only the zone is changed. So this design spectrum doesn't consider a soil. Soil consideration not gone to the design spectrum. Second, the liquefaction introduced only on the 2006 version. Okay, so there is no other version talk about the liquefaction. That means code which people who designed their building before 2016 may not even thought about the liquefaction, but liquefaction is the one of the major hazard, particularly the apartments. Okay, the people multi-store construction of buildings, this code has been extensively used, particularly the architect. So the architect, they say that we follow IS code, they model and they do. So but without having a knowledge of all this information, whoever designed their building as per even IS code, that has a question on is stability. Okay. So it is an individual responsibility to know and enhance their knowledge, and before you invest or construct your house, you should be ready and see that your house is safe against earthquake, particularly people who are living in the high seismic zones. Okay, high seismic zones such as Delhi, northern India, several parts of the North India and the Bhuj and other related areas. So as I told you that earthquake can occur anywhere, there is no this one, only the return period varies. As we don't know, many of the earthquakes actually occurred places where there is no identified fault, there is no identified zone activity. For example, 62 zone, some place marked as a zero seismic zone, there was a big earthquake occurred and caused intensity of 8, 9, okay, where it was intensity 4 and 5 was expected. So something like that, that kind of mismatching up the representation of the data, or we have less data to show the complete activity. So in that case, taking risk, okay, is always not good or not advisable. It's better we be prepared. So the construction cost due to the seismic design will increase only marginally, not so much. When you consider your life, actually that cost is nothing only, but you should also know that what you should consider. As I told you that if some people say that I designed as per IS code, okay, but if they designed without considering liquefaction, even if we design a building, the building will be intact. Because of the foundation soil failure, the building will fall. So such kind of scenarios has to be accounted. Right now that process is going on as a preparation of microzonation map. So hopefully the future, okay, I don't know how many years future it will take to produce a most reliable zonation map which consider all the part of microzonation component and give the zonation map state of art knowledge and upgradable. As we have seen in the OpenQuake software, the map should be upgradable. So that we can do and then produce a most reliable map that will be useful for the design. So as I said that we have discussed the concept and methodology and the importance of the engineering seismology several aspects. So next couple of classes we are going to talk specific to Indian seismicity, seismic hazard analysis, okay, for the typical area, okay, deterministic, probabilistic and a new way of rupture based analysis, which was we are talking and we have discussed and published those papers. So these aspects will be discussed in the coming classes. Okay. So thank you very much for watching this video. So we will see you in the next class with discussion on the seismicity of India. What is the seismicity of where earthquakes are occurred, when it's occurred, what are the places are active, how it is active, what are the evidence they shown, what are the source zone, all those information will be discussing in the coming classes. Thank you very much for watching this video. We will see you in the next class. Thank you.